Hello, and welcome to the Road to Genome podcast. This episode is being brought to you jointly by the Genomic Medicine Services in the North East and Yorkshire and the East of England. I'm your host, Helen Bethel, Genetic Counsellor and NEY Workforce Development and Education Lead. I'm delighted to be joined by Professor Julian Barwell, clinical geneticist, who is here to tell us about the great variety of work he's doing within the East Midlands. So thank you so much for joining us, Julian.
Thank you so much for having me on. That's fantastic.
Can you tell us then what your current job titles are?
So I'm a consultant clinical geneticist, and most of my work in the hospital is based on seeing people who have got a family history or are affected by cancer, where people are worried that there might be some sort of familial link. So we see a lot of people, for instance, who have had breast cancer, bowel cancer, or ovarian cancer, but all sorts of different types of tumor groups. And then I'm also involved in seeing people who have got some other types of conditions. So I do a little bit of work in dermatology, endocrinology, and also immunology. And we're also in the process of setting up a hub for people affected with a condition called Fragile X. And Fragile X is the most common cause of inherited learning difficulties in boys, and it's associated with everything beginning with the letter A. It's like going back to Sesame Street. So anxiety, autism, additional needs. Sometimes in some children, it can cause agitation and aggression, but also for the carriers, the females, because it's a condition that girls tend to carry and boys tend to be more severely affected. They can go through an early menopause, which I call anovulatory, which is a bit of a cheat. And the grandparents often have a form of tremor, which is called, often confused with Parkinson's, but is actually called ataxia as well. So we're trying to set up a hub to support families with additional needs as well. So that's what I do clinically, but I've got a lot of other hats as well.
Yeah, the hub sounds great. So what kind of support does the hub give?
So at the moment, it's mainly underpinned by research. So we've been involved in a study looking at the impact of a cannabinoid-based gel without the psychedelic component. And we're also got a relationship with a group in the community called Relate, which used to be the marriage guidance. And that's to support not only couples who have children with autism, but also to support the siblings who may be unaffected, because there can be a large impact on the other family members, but also as a family unit as well. But we're also looking to set up a national and international database for Fragile X and to be able to offer other research and look also at how we can track the progress that children can make, using something called the toolbox as well, which will be able to help assess and track things like IQ over a period of time, because a lot of these children are nonverbal and find it very difficult to use classical tests. So we're working with educational psychology, but also occupational therapy as well. And if required, linking in with other groups such as community pediatrics, general practice, gynecology for the mothers as well. So it's thinking holistically about the impact of having a child with additional needs and thinking, how can we support those families? And we work very closely with the Fragile X Society, but also this is a partnership with parents. So this is not something that we are leading alone. This is an absolute co-creation project, which is really one of our core values that we hold dearly.
And what has been the response from families?
It's been fantastic. A number of families have come forward for the research, but we've run a couple of conferences, because the most important thing to do when you're starting an initiative like this is actually to work with the families and to hear from the families. So you've got to have that listening as really embedded in what you do, to find out not what you think are the problems that these families face when they get a diagnosis. Often when people get a molecular diagnosis, we think in advance, well, that's going to open doors. Well, actually, in the additional needs community, often it almost closes doors because people start to worry about, well, what's the ceiling for my child in a particular domain? So we're about what are the challenges that the families and these individuals with these conditions have? How can we make life that little bit easier? Access to medication might be part of the answer, but it's crucial that we think about the family unit, and also access to perhaps additional diagnosis like autism or ADHD, but also making sure they can access psychology, speech and language, physiotherapy, occupational therapy, because there's huge amount that can be done, especially if you can intervene early. We talk a lot about neuroplasticity now. So this idea of, can you build the connections in the brain that will make it easier for that family to get into a supermarket or into their church or synagogue or temple or mosque, but also make that school run easier in the morning, because often children with autism and Fragile X may struggle during transitions. So there's a number of different techniques which might help, and they're not always going to be medical. So it's really important that we work with families and understand what it is that we're trying to help. But in the future, there are new drugs coming along, and also the potential for gene therapy. And we want to be ready for as and when the time comes, so that we can offer choice to families, so they can think as to whether or not they want to go down these allied specialties like occupational therapy, or in addition, whether or not they'd be interested in any of these new technologies. And so we want to be ready for when 21st century medicine really hits in.
Yeah. It sounds like an incredible holistic service for that community. Is it just a local service, or is it nationally?
The aim at this will be national. So we spent many years developing what's called Research Space, which is a clinical research facility. Now, that is a very good place to be able to run this, because it's a secure unit, it's quiet, we've got a special needs consent room, which has got soft play, and we can adapt the lighting. But we've also got rooms with a space theme, we've got interactive floors, 3D televisions, and distraction aids if we need to do blood tests. So that's great from a research perspective, but we're also looking into the community for some of the other clinical aspects as well. This isn't the sort of condition you can run on a busy corridor in a standard outpatient, because a lot of our patients like to run up and down the corridors and need that little bit more time and a bit more space and understanding, because obviously going into a hospital environment can be overwhelming for some children. Yeah, absolutely.
Yeah. So is this role what you always aspired to do? How did you get into this work?
Not really. My main area, as I said, is familial cancer. I can remember being 6 years old and saying to my best friend's mum, I was at a sleepover, and I said, is his dad coming home from work? And she said, darling, he died, he's not coming home. And I was 6 years old, and that struck a chord with me about the importance of keeping families together. And then when I was about 15, 16, I started watching MASH, Mobile Army Surgical Hospital. And although I knew I would never be a surgeon, because I can't even cut a chicken, or let alone a human, but I was struck by the compassion and the humor of MASH. And then when I was 17, I had an epiphany, of all places, in a laundrette when I was reading an A-level biology book, and the structure of DNA opened up on the page, the double helix, and suddenly hit me how all nature was connected, and that obviously you only look about 25 today, but your oldest gene, of course, is 2 billion years old. So you're 2 billion and 25 years old. And where we have come from genetically and biologically, and how we're all linked to living things, became clear to me. So it's really the triad of keeping families together, trying to help people, but being underpinned by what actually connects us to nature. I'm a great believer that we don't live on Earth, we are Earth. And that's one of the things we when we go out to schools and we talk to them about our work, I think it's really important to get across is that genetics and DNA is not just about a code for our body. It's actually a biological clock. And I like to think of the film The Wizard of Oz, and there's a bit towards the end where it gets a bit scary, and sometimes that's the time for a bit of a lube break. But that's when she's in the castle and the Wicked Witch turns over this huge hourglass and says, "You've not got long." And the way I like to think of it is your DNA when you're born is at that midpoint of the hourglass, but genetic change is still going in your body at all times towards the bottom, but also you may be passing on your genes. So this biological clock that we have, we just borrow it for however many years that we're here. So I like to think of our DNA as more than just that code, but as a real part of our essence. And it's such a big feature of cancer. And we say, well, cancer, it's not a genetic disease. Well, it's purely a genetic disease. It's just it's not always inherited. So most of my work is in the familial cancer space, and I'm delighted to be able to try and keep families together for longer, because I've always been brought up knowing of the impact of cancer and a late diagnosis, and not really being able to understand what's driving it and what can be done to prevent it. But actually, the next big event happened when we had a close family member, a very close family member diagnosed with autism in our family. And that very much changed our lives about 20 years ago. And I found that very difficult at the very beginning, as many families do. And it wasn't something clinically that was in really my area at the time. But I met a family who had just been diagnosed with 2 boys with Fragile X. And they reached me at a time when I was looking at developing further research capabilities, and we brought together a research space. And they said, look, we've just got this diagnosis. We're finding it hard to access additional services. What can we do? So I was able to talk about a lot of the services that we developed in the cancer space. So I do a lot of work with support groups. For instance, I help run a National Hereditary Breast Cancer Helpline. We've done a lot of work in the prostate cancer space, which I think we will be talking about as well. But we'd also done a lot of events driving new services. We come up with something called the Medical Supermarket, where we'd have a couple of talks, but then we'd have a series of aisles where we'd have psychology, genetic counselling, stakeholder groups, physiotherapy, dietitians, and people would walk up and down and choose who they would want to talk to. So a real holistic approach to cancer. So I said, well, look, I'm now in a place, part of a mid-career life crisis, perhaps. and I was thinking, you know what? I'm going to help you, and let's see what we can do and really drive this forward. So I'm really excited about the Fragile X work, but it's only been something that we've been developing in the past few years. So it's a really exciting new development, and it's going beyond diagnostics. I think it's really important that as more genetic testing takes place in what we call secondary care, so your cardiologist doing this genetic testing if someone's got a condition that might be inherited, it's due to for instance, a heart muscle problem or an electricity problem. I think that in time, people will be doing a lot more tumor genetic testing. And as a result of that, I think it's really important that genetics thinks about what its position might be in the future. Part of that is going to be about supporting people with genes. Once you get a genetic molecular diagnosis, that is only the end of the beginning. And it's really important that we think about how to support families, because their lives can be turned upside down, not just for cancer, but for these rare conditions as well. And I'm just really excited to try and see if we can help people, not purely on just accessing one drug, but actually how can we help that family unit, thinking about the multiple generations, not just the people with the condition, but the impact on the others and the relationships. We know that up to 50% of relationships can break down within 5 years of an autism diagnosis. So for the parents' relationship can be put under enormous strain. So I just think it's really important that genetics starts to think about how we can help these families beyond purely giving a diagnostic result. We can't do it all. There's up to nearly 7,000 rare diseases, but there are certain things we can do. And Fragile X, there's really exciting new opportunities. And so the stars aligned, and here we are. So it's a really exciting time.
So you mentioned your prostate work. Can you tell us a little bit more about that?
Yes. So we'd already met Prostate, which is a fantastic local charity, as well as Be Me Cancer, which is a group being led out in the Nottingham region with a particular interest in men of African, Caribbean ancestry, because we know that the risks in that population are much higher. Men often present with a late diagnosis, and it can be very aggressive. So the classic risk of 1 in 8 for the general population, well, the risk can be almost doubled in men of African and Caribbean ancestry. So we've done a lot of work already in that community, but we know that there's a greater push towards doing genetic testing in tumors. So we already said that we do a lot of testing for people to look for inherited diseases, but gene changes do occur within the tumors as well. So I always say that a tumor may have up to 20,000 different gene changes within it, but perhaps only 5 to 10 are actually driving that tumor to develop. And some of those gene changes may be particularly helpful as treatment targets. It's what I call the Death Star effect, although other sci-fi movies are available. So the Death Star effect is this concept that you can't destroy the Death Star until you've got the plans. Yeah. So if you can understand what is genetically driving the tumor and what potentially might be its weakness, then you can target a treatment towards that. So thank you. So in prostate cancer, there's a particular type due to a gene change called BRCA2. And that type of tumor can often be quite aggressive if not picked up early. But there is a new type of treatment which actually tackles the weakness within that particular driving of the tumor. And that is to do with the way in which, when a DNA is completely broken in two, called a double strand break, is repaired. So look, the analogy I have is if you were to think of something like Tower Bridge compared to London Bridge. Tower Bridge is a really spectacular structure with two very large turrets, for want of a better phrase, and a cantilever in the middle. Now, if that were to be destroyed, how would you know how to rebuild it the same? Well, you would need the plans to be able to do that. And it's very much the same if your DNA gets completely sawn in two. You can either just try and squeeze the ends together, but you may have lost information. But the other approach is to use a template or use the plans to be able to actually be able to fix it and make sure the bit which has been lost in the middle is identical to how it was before. And that's exactly what the BRCA2 gene does. BRCA2 gene, what it would do if Tower Bridge was explosion, it would bring the plans to the engineers so they would be able to rebuild Tower Bridge exactly the way it was. So what happens if your BRCA2 gene doesn't work is you can't repair the DNA in that way. And so then those cells become very vulnerable to being destroyed. So we can use that information. And we saw a lovely chap at the beginning of this particular journey when we wanted to introduce tumor testing. Now, prostate cancer is not an easy model to start tumor testing for a number of reasons. One, technically, it can be very difficult to fix because we tend to fix it in something called formalin to be able to cut it into pieces to be able to send off for testing. But also you can have more than one tumor within the prostate cancer. And that's a real challenge because unlike a lot of tumors, a man might have 3 or 4 different areas where there's prostate cancer as well. But we'd been able to help develop with our colleagues in East Anglia, who've done a lot of research in this area, Professor Colin Cooper, to be able to develop a way in which we could actually process and fix the prostate cancer. So we did that with our colleagues, John Dormer here, who leads the prostate cancer histology team. And then we were able to send it off for genetic testing to our laboratory hub in Cambridge to be actually able to find that BRCA gene change. And from there, we were able to then go back to Andy and say, do you want to know if this is inherited? Because we found it in his tumor, and we know about half those gene change within the tumor will be inherited. And we were able to find that and then be able to offer testing for his wider family. And we did a video about that, which we released with Andy, with his consent and his family to explain this. And we did very similar things with men from the African Caribbean community. But what's really important is you've got to go out into the community rather than just staying within the confines of your hospital. So we go out to Domino's, not the pizza restaurant. Other pizza restaurant chains are available, but we went out to Domino matches because they men from these communities played Domino's. And we talked to them there. We ran an event at Leicester City Football Club, and we had Emil Heskey, who was there, which was fantastic. And we had support from Lenny Henry as well, explaining to men about the risks of prostate cancer and the importance of getting tested, because by the time men come forward with symptoms, often it's difficult to be curative. But it is difficult with prostate cancer, and we don't urge all men to get screened at all times. We're looking at those who have got the strong family history, and also men who have got African and African Caribbean ancestry. When you're trying to work out if you've got a family history, I take you back to before you were born in about 1983. When before Simon Cowell came along, we had Ted Rogers and his Dusty Bin on a Saturday night. And he used to have a catchphrase, I'll try and do it without abusing you. It's the old 3, 2, 1. So if you've got 3 relatives across 2 generations with one diagnosed under the age of 50, and you've got a couple of those, so 3 affected relatives, 2 generations, 1 diagnosed under 50. If you've got a couple of those, for any condition, start to think, could this be inherited? So we've been getting this message out about 3, 2, 1. And also explaining that breast, ovarian and prostate cancer can be linked. But it's just really important to be careful with prostate cancer, because although you can pick these things up and improve the long-term survival, the prognosis, there can be problems with overdiagnosis causing impotence and incontinence. And it's called what I call the rule of 15, which is a bit like Sesame Street. We talked about, but it's starting with the letter A. So this is brought to you. So I've got a quiz for you now.
Okay.
So here's the quiz. So all the answers are 15. So what percentage of men over 85 at post-mortem don't have prostate cancer cells?
15%, I'm guessing.
That's a good start. Excellent. Well, I think we're going to do well here. But what proportion of men over 85 with prostate cancer die because of their prostate cancer?
15%.
Brilliant. About 1 in 6. So it's about 15%. Now, if you write to all these people at very high risk and say, we're going to do an MRI scan and we're going to do a PSA and we're going to have a long chat to you and we're going to sort all this out for you, and you write to them cold, what proportion do you think will come forward to go and have that
15%.
chat? 15%. Now, you may have heard of the PSA blood test. So this is a blood test which you've got to avoid sexual activity for a couple of days before you have the test, or riding a bicycle or a motorbike, and definitely not doing both at the same time for at least 2 to 3 days prior to having the PSA. But what's the chance of having a significant tumour with a normal PSA?
I'm imagining 15%.
It is 15%. But if every man over the age of 50 did come forward for screening for an MRI, how many hours a day would it use every MRI screen in the NHS in this country?
It won't be 15%.
It's not 15%. It's 15 hours a day.
Okay.
So this is the challenge, is the consent process is difficult to actually explain the pros and cons of screening. But also, could the NHS really cope
with 15 hours a day?
With 15 hours a day. So that's why we think it's important to target those who are at high risk, target the disease that's likely to be aggressive, target the disease that's likely to be familial, and target also how best to treat the individual. Move towards that precision medicine where we treat disease for what it is rather than what it looks like under a microscope, which is more than 500 years old. And in the same way with screening, we screen people not on age, but on risk. And once you've done that and you give them treatment, you give them treatment at the right dose, for the right person, first time, every time. And that is often partly a genetic trait as well. So this idea that we treat everyone the same is horrific. And we'll look back thinking it was like Elizabethan, not our late dear Queen Elizabeth II, but Elizabeth I with the leeches. We need to give people the right drug, and that we need to use genetic testing to see how they're going to break down and use the drug. It is outrageous that we are giving people the same drugs. Up to 1 in 6 or 1 in 7 drugs are actually potentially going to cause harm, either because they just don't work or they cause unnecessary side effects. So we're not suggesting anyone change their drugs or anything, but we do know, for instance, statins, some people get terrible side effects, for instance, with muscle aches, and that is largely a genetic trait. So people would have more confidence if they knew how their body was likely to react. And we're also working on a system whereby, apart from on your phone, be able to QR code your prescription so you can check how your body would react to that drug, but also see how other patients with your genetic profile responded to that drug, like a personalized Amazon rating. Other delivery websites are available. So you can build your confidence by how other people responded to that drug who are similar to you. And there are a lot of people in the East Midlands who won't respond well to certain types of drug, but we just don't yet test for it.
Where do you see pharmacogenomics is what you're talking about. Where do you see it sitting within the NHS when it eventually comes?
Well, it's a massive problem because it doesn't sit purely in primary care or cardiology or psychiatry or clinical genetics. Clinical genetics was set up for inherited diseases, not response to disease. And I like to think of genetics and genomics as a Venn diagram, really, two interlinking circles with on one side genetics. And we've already said that genetics is a study of a biological clock. So it's very good at explaining the past. So it's a bit like looking up at the stars at night. If you look up at Betelgeuse, which is the star at the top left shoulder of Orion, that light was released around the Battle of Agincourt. So 700-800 years ago. So you're time traveling, and that's what you're doing with genetics. But genomics is about trying to predict the future by bringing together lots of different data sets. So that's the other half of the Venn diagram. The middle bit is the personalized medicine. So that's the interconnection. So genetics explains reason. Genomics predicts risk, but precision medicine, personalized medicine is about trying to understand response. So these are the 3 R's of genetics and genomic medicine. And that's the way I like to think about it. So we're only really going to be able to make real progress when we actually bring different data sets. And that's the importance of patients being involved in their own data, because then they can actually say how they got on with that medication. So where does it sit? It sits with the patient.
So you mentioned before about the engagement work that you've done with the communities around prostate cancer. Can you tell us a little bit more about the other engagement work that you're doing at the moment?
So we started originally building on the work that was carried out by one of my predecessors, Professor Annette Cashmore, who set up a program after DNA fingerprinting was first discovered in Leicester. So they would extract DNA from a banana, and then they would go on and solve crime scenes for the children to come into the university and understand the university experience. And from there, we set up something called Health Education Reaching Out Hero, which was to help children think about the choices they made in a school day. So could they ride off a mini Mars bar on an exercise bike? How much sugar and salt did they eat in a week, and could they pour that out, for instance? So think about food and exercise links. And that became something called Supporting Families with Cancer, which was work with Macmillan. And that's where we came up with the 321 project and community outreach. And we developed the first YouTube channel for genetics and the medical supermarket. So that all led to a really good place for when David Cameron came up with the idea of the 100,000 Genome Project, because we already had a lot of these links and the National Hereditary Breast Cancer Helpline from the medical supermarket. And we're able to develop a patient panel, and Rebecca got involved through that to help with the 100,000 Genome Project. And because we'd done a lot of work already in the community, spreading the word about genetics and genomics, we were able to work with a family who had 3 sisters diagnosed with breast cancer within 13 months. And we told their story, and that went from Leicester Mercury to East Midlands Today to the BBC Breakfast Sofa within 48 hours. So that put us in a really good place when we were starting engagement and outreach. And we wrote parliamentary select committee reports with the patient forum, and we ran genomics conferences. And we started to realize the importance at that time of thinking about personalized medicine as well. And that led us to starting to think about driving teaching and training, not just for the GPs that we'd led for the 321 project, but actually to think about targeted treatments and the Death Star Analogy project as well. So we came up with a whole series of training for postgraduates as well, for breast surgeons and for oncologists. And in the meantime, as part of my midlife crisis, I'd been working on joining a choir and then into musical theatre, and I started to write. I wrote some drama sketches, and it's crazy. I wrote a drama sketch in 2019 for the first year medical students of what it would be like when they started to work, and we brought the house down with a sketch about a consultant in 2039 being at home on Skype in a t-shirt. And it brought the house down, little knowing that within 6 months with COVID, of course, that happened. And nearly everything that we wrote would happen has already happened. And that was going to be 20 years in the future.
Wow.
4 of the things that we predicted happened between writing the sketch and performing the sketch.
Wow.
So we talk about things going to be slow. Well, actually, of course, World War I led to a huge revolution for the unions and votes for women. World War II led to the welfare state and the NHS. And COVID, of course, has had a massive digital revolution. And we've done a lot of work on our digital projects since then. And in patient empowerment as well. And so the patient empowerment is a huge part of the work we do now. But also having got the writing bug, and we'd already been working on clinical genetics and genomics at a glance, which is 90% a Leicester-based project from the Leicester Royal and the General and the Glenfield for clinical geneticists and other colleagues. We wanted to do something for school children. So Nita Lakhani, who's a brilliant registrar, now one of our consultant colleagues, we're delighted to be working with her. And she helped lead the clinical genetics and genomics at a glance. We together wrote What is DNA, which is a children's book. And that came out of, would you believe, I was scrolling through Facebook, other social media sites are available. And people have been engaging with talking about whether or not they like Brussels sprouts. But rather than 50 engagements, it had 50,000 engagements. This country has a bizarre love of talking about Brussels sprouts, particularly at a certain wintertime festival. Other seasons are available. And so this sparked an idea in my head about, because we know whether or not you like Brussels sprouts is a genetic trait. And I wondered, well, what other topics feed into that? So why do they put blue in a traffic light, which of course is related to color blindness, which is an X-linked inherited trait? And we've talked about X-linked with Fragile X, for instance, things that girls may carry but boys tend to be more affected with. But other principles as well. So what came first, the chicken or the egg? Is granddad a dinosaur? Are you 50% a mushroom or just a fun guy? Apparently my comedy career hasn't quite yet taken off, but I'm sure within the time this podcast is launched, the book and these concepts will be on the West End. So what we've done with the children's book is we're trying to go out into schools and use these contexts, because I hope that one day my legacy, I hope, is that a child in a laundrette, other washing facilities are available, will open up my book on DNA, and they will carry on that biological clock journey for themselves in the way that they want to. But hopefully you want somebody to be as inspired and enjoy the journey as much as I have.
Yeah, and the book is fantastic. It really is great.
Oh,
I highly
thank you so
recommend
much.
it as a read. So tell us more then about your work in schools that you've been doing.
So when we go out into the schools, it depends on if it's primary or secondary. I went out 2 weeks ago to talk to a series of A-level students about careers in biology and medicine as well. But in primary schools, we go out there and we really want to talk about their relationship with their DNA and also with nature. So we go out and we do our DNA wraps, and all, in spite of what my family think, I got the ultimate affirmation when I said to a group of 11-year-olds, right, it's time for another wrap, and they went, yes. So what more do you need? So I have actually professionally recorded a wrap in the same studio as S Club 7 and Blue, but I'm not sure if that raises me or diminishes them. Other pop groups are available. But I've greatly enjoyed it, but it's just a bit of fun. It's one of my mantras, really. Take your career seriously, but not yourself. It's important to sometimes take a risk, have a go. And life's not a dress rehearsal.
Yeah. Fantastic. So I'm going to ask you to do some rap for us in a moment.
Wow,
maybe,
that better be right at the end. We don't want viewers to turn off before we get to that point.
It might be worthwhile asking you that towards again. So yeah, that'd be great. So in terms of your career, Julian, then you mentioned about the fact that you were interested in genomics from a very young age. So when you went off to medical school, did you know then that you wanted to pursue genetics within that, or was it something that evolved throughout your medical school education?
Yes, because of course, for those of you that have been listening very attentively, you'll know that the key ages were 6, and then 15, and then also during A-level as well.
Yeah.
So I did an intercalated BSc in human genetics with an interest in familial cancer at that time. So I was 21 at that time. So I went from there to keep going back to the laboratory in the summer holidays. That's how I rock and roll, to be able to expand my interest in familial cancer. And then after I'd done my general medical training and my year in A&E and my house officer years and my professional exams, I went into clinical genetics as a registrar, when during the middle of those years, I did a PhD in familial cancer susceptibility, sponsored by Cancer Research UK, and was supported by Professor Shirley Hodgson, who's only just retired clinically. Now, my very first clinic in clinical genetics, I sat in with her, and I was there in her very last clinic 30 years later. So I got a terrible feeling that means that I'm now senior and have to behave like a grown-up, which is a bit scary. But she's been a great mentor over the years. And that was supported by Sir John Byrne through the Cancer Research UK. And I believe that he has also done on one of these podcasts. So it's great to be following in his illustrious footsteps. One of the real superstars of the specialty.
Yeah. What do you think in the time of your 30 years so far, what has changed within clinical genetics?
So I think the key thing that's changed is the role in the past, because genetic testing took so long and you could only generally test one gene at a time, was at that point you had to what we call gatekeep genetic testing. So you had to say, I remember reading this journal from 1965 and the gene that we need to test for is this. An incredibly brilliant skill, and there are some clinical geneticists still out there who I'm in utter awe of their ability to do that. But with the rise of gene panels where you can test multiple genes and whole genome sequencing, internet databasing, The databases that we have and journal literature searches, the role now is changing. So it's what I call the bullet hole theory. And this is that it's not, can we do a test? It's what on earth does the result mean? Now, back in the Second World War, loads of our airplanes were being shot down. And they wanted to put some extra armor on the airplanes, but didn't know quite where to put it. So they brought in a mathematician and an engineer and said, what should we do? Where are we going to put the armor? And he said, well, can you draw a distribution map of all the bullet holes on our airplanes? So they did that. They said, oh, fantastic. We can now see where are all the bullet holes. And he said, of course, put the armor where there are no bullet holes. And the answer, of course, is, well, the bullet holes which knock down the airplanes you never see. And it's very much the same with our genome. We all have 400 bullet holes throughout the coding sequences for our genes. So our genome is made up of lots more than just our genes. But in our genes, we probably have about 400 subtle changes. And actually, it's difficult to know what they mean. It's what I call the rule of 5%, which is if you test a series of genes, there's about 5% chance you'll find a subtle gene change, but only about 5% of them might be important. So how do you work out what's important? And sometimes by looking at the chemistry, that can give you a clue. But the key is often databasing and bringing lots of different data sets together of people who don't have the gene change, but also people that have the condition. So you can understand what so-called normal looks like, but also see people who have got that extra kidney or a problem with their heart or a different cancer running through their families. And databasing is really important, but of course it needs to be from the whole community as well, because this has been one of the great challenges in genetics, has been to make sure we are representative of the communities that we serve in terms of access, but also in interpretation, because we all have differences in our genome. They can be very subtle, but there are differences as well, and we need to understand that. And that goes from access to clinic to our reference genomes all the way through to the way in which we treat the patients. So equity of access is important, but it needs to be also on a molecular level as well.
Yeah. What do you think is your biggest driver for the work, all of the amazing work that you're doing? What's your biggest driver?
It's to reduce suffering and keep families together for longer. Has been what this has all been about. It's also been about trying to have a sense of a journey within the specialty. I don't just want to turn up, see the patients who are on my list and go home. My patients are the community. I try and think, how are they going to reach my clinic? What support can I give them after the clinic? How can we make it easier for people to put all of those bits together from their family together? When I arrived in Leicester, I was seeing people with 6, 7, 8 members of their family affected with a condition before the first one was referred in. We don't see that so much anymore. And I think that's a lot because of the raising of the profile of genetics through things like Angelina Jolie. She had preventative surgery, tripled referrals nationally, doubled them locally. We wrote a paper you may have heard of called the Angelina Jolie effect, which went into 46 countries, helped me get my professorship. I always hoped she changed my life. It wasn't quite what I had in mind, but partly because of those factors, because of things like 100,000 Junior Project, but also us going out into schools and talking to GPs and secondary care specialists. We are better at finding the right families. I'm not saying we've got it covered, but we're certainly a lot better. And the service is massively increased. We've got better genetic testing. We've got genomic testing. We've got more targeted screening. We've got better treatments. We're working on more targeted treatments. We're paying patients front and center of developing our services, but also, for instance, developing these patient-facing tools. For Lynch syndrome, which is a bowel and gynecological tumor susceptibility condition, we've developed a patient-facing app. And that came of me working on the wards during COVID. In my first week of going back, I told a young nurse, I haven't been on a ward like this for 19 years. And I thought I was doing rather well. And then she said, have you come out of retirement? And again, like the Wicked Witch and the Wizard of Oz, I started to somewhat melt. But I realized on the ward that there was a complete mismatch between molecular biology and a reality of clinical experience. So we want to put the patient at the front and center of that. And so that's why we've been developing these patient supporting aids as well, so that you can bring genetics out of the hospital onto the high street. And that's all very much part of Lord Darcy report. Can we get genetics onto the high street? Can we try and start thinking about trying to prevent disease rather than constantly just think about treatment as well, and putting patients at the heart of everything that we do?
Yeah. And that really comes across, Julian, that everything that you have talked about really goes back to that very first initial reaction at 6 years old about keeping a family together and completely putting that patient at the front of it. And I think clinical genetics is just that, isn't it? It's about the family. I heard it described once as family medicine, rather than in many, many other areas of medicine, you're treating just the person in front of you rather than that 360 family around them. So it's been fantastic to talk to you and hear your passion for that. But my last question has got to be, can we hear a rap?
Okay, how about that then? So what I'll do is I'm going to tell you a little bit about the story about how the structure of DNA was first discovered. And then we talk about this in the book. And if this goes well, the idea is that we would do this for all of the chapters. So there were two scientists, Watson and Crick. They came from Cambridge, didn't want to miss a trick. So in 1953, they wrote just 2 pages explaining life on Earth across all the ages. Wilkins and Franklin had found a DNA spiral. Soon their journal paper went totally viral. A strand spins up, the other goes down. A sugar-coated ladder twisted tightly around proteins that switch both off and on. Genes cross generations like father to son. With just 4 letters, A, T, C, and G, the code creates a whole of biology. Because explaining replication had always been the trouble, and the problem was solved when the helix was double. The 4 letters always pair off exactly the same, so DNA can copy itself again and again. So biology changed in a 2-sided letter like so many things in life. The simpler, the better. Drop mic.
Brilliant. That's brilliant. Thank you so much, Julian. Thanks for joining us today. If you would like more information about the topics that we have discussed, then you can find these at our website, www.ney-genomics.org/podcasts, where you'll also find all the episodes in our podcast series. These can also be found on Spotify, Apple Podcasts, and all other podcast platforms.